Hi to you watching this video. So for this video, we are now on module number 3. So stresses in a soil mass. Okay. So for unit 1, we are going to discuss about stresses caused by a point load. So in this diagram, we have here a point load and we have here our soil mass. So given the point load here, we are to determine what would be the vertical stress that would be caused by this load here at a certain depth of z with a distance of x and y from the point of application. So for example, we have here our soil mass. We have here the uh, sigma y, sigma x, but what we are interested in would be the sigma z. Okay, so according to Bosinesk in 1983, the normal stresses at a point shown caused by a point load R. We have here delta sigma x and we have delta sigma y. But what we have said a while ago, we are interested in the change of sigma z, which is caused by the vertical point load at a certain distance. So delta sigma z is equivalent to 3p z cubed over 2 pi L squared. Actually, this method is the Bosinesk solution. Okay, so we have here mu is equivalent to the Poisson's ratio, while r is the shortest distance on the surface to the point load to the sample point, and L here is the shortest distance to the point load to the sample point. Para hindi kayo malito, yung R natin is just on the surface. So it would only involve the X and the Y coordinate. But for the L, it is the shortest distance from the point of origin to the point of the load sample. So from that point to this point. So that would be the L. Okay? So yun yung kanilang pinagkaiba. If we want to simplify equation 3.5, we can have it as substituting by the value of r. Since x squared plus y squared, the square root is equivalent to r. So we can substitute this with r squared plus z squared. And then we can have now L squared is equivalent to the square root of r squared plus z squared. Now we are going to substitute equation 3.6 with our equation 3.3. So if we are going to substitute the value of L here and we are going to expand, that would be equation 3.7. So pinalitan natin yung L here. We have r squared plus z squared raised to 5 over 2. Then we extract p over z squared. Then the value that is remaining would be equivalent to the value of I. Okay, so since we have this second equation here, the second equation can be used for our table. So we can refer to table 3.1 or figure 3.2 for variation of I1 for various values of R over Z. So this one here is the table method. So all in all, we have two methods. We have the equation method and we have the table method. Okay, so this one would be the table method. Note that if the value of r over z cannot be found in table, it is better to use the equation method or the Bosinesk equation to avoid possible errors due to interpolation process. Because if we cannot search for the value of r over z or r over z here, then we can do interpolation. But of course, since we will be having interpolation, we can be having error. Okay, so where this value came from? This value came from this table here. So we have a table here. So we have here r over z. Pag nalaman na natin r over z, project it vertically. Pag tumama na siya dito sa ating curve, then we project it horizontally. That's where we get our value I over 1. So if we do not have I1 here, it is better for us to use the Bosinesk equation. Okay? So let's have here an example. So 10.7 of page 347 of your book. So point loads of magnitude 100, 200, and 400 kilonewton act on point B, C, and D respectively, as shown in this figure. So we have here 100 kilonewton, 200 kilonewton, and 400 kilonewton. So determine the increase in vertical stress at A depth 6 meter below point A. So we have here the point A. So yung 6 meters below point A daw. So use Bosinesq equation. So first we need to identify what are the forces. So the force at B is 100, the force at C is 200, and the force at D is 400 kilonewton. Now just to show you ano ba yung itsura niyan, ganito yan. Okay? So this is an isometric view. So you have here point B having 100 kilonewton, point C having 200 kilonewton, and point D having 400 kilonewton here. And we are to determine the stress, delta, what do we need to, the stress, increase in vertical stress at point, at a depth of 6 meter below point A. So let's say this is our point Z. Okay. So if this is our point Z here, so we need to determine the delta sigma Z. Okay. So now we have 3 points, so, or 3 forces, no? We have the force at B, force at C, and force at D. Therefore, it will be a summation of the forces, no? Or the contribution of these 3 forces. So it will be the summation of delta Z at point A is equivalent to the summation of delta Z at point B plus the summation of delta sigma Z at point C plus the delta sigma Z at point D. So it will be a combination. So what is our working equation then? Isn't it that a while ago we said that this is our working equation? Now to for easier solution, it would be best if we are going to have it in tables. Okay, so take note, the points here is point B, C, and D. So point Z and D. So you have here the corresponding forces. So you have here 100 kilonewtons, 200 kilonewtons, and 400 kilonewtons. Okay, and what are the variables here? The variables in our working equation would be, we have the P and we have the L. So ito yung mga varying equation natin. But for this, for others, it is constant. So we have 3 and we have Z. Our Z here is 6 meters times 2 pi. So we have P, we have P here. Next would be the L. So for L, sabi natin kanina, L is the depth, or it is the distance, or the shortest distance from the point of application to the point that we are the stress that we are looking for, and that is this point. Okay, so let's try to insert here. Ito yung point na hinahanap natin. So for point for LB, ito yon, from this point up to this point. So what are the coordinates? So we only have 6 by 6. Okay, so we have here 6 meters by 6 meters is equivalent to the square root of bring out your calculator. We have 6 squared plus 6 squared, that is equivalent to 6 the square root of 2. Okay, so yan, it is best if we have it in square root, so we can avoid error due to decimal, or not error rather, but discrepancy due to decimal. Next would be from point the L of C. Now for the L of C, it would be from this point up to this point. So what are the coordinates coordinates involved. So assuming that this is our x-axis, y-axis is here, and z-axis is here. No. Y-axis, we have x-axis, and we have the z-axis here. So what are the coordinates? So we have 6 by 6 by 6. Diba? So we have x, y, and z coordinates. That is the PDF. Yun yung in-upload ko sa that will be your module na i-upload. So we have here 6 by 6 by 6. Okay? So pag dinagdag natin yan, it would be 6 the square root of 3. Okay? So yan. 6 times the square root of 3. Okay? Palitan natin yung nasa loob nung square root natin. That should be 3. Next would be the 400. So for the D400, it is naman at this point. So what are the coordinates involved? Now for the z-axis, it is 6. For the x, it is only 3 meters and it is positive. And for the z, take note, magkakapantayan, point A, B, C, D. So therefore, the z-axis, the z coordinate is 6. So 6 by 3 by, or 3 by 6 by 6. Okay? So next, we have 3 by 6 by 6, and the answer for that should be 9. We are now ready to substitute it to our working equation, which is delta sigma z is equivalent to 3p z cubed over 2 pi l raised to the 5th power. Okay, so we have here 3 times what is our p. P here is 100 kilonewtons times we have z, and z is equivalent to 6 meters divided by 2 times pi times l. L here is we have here 6 times the square root of 2 raised to the 5th power. Next, for point C, we have here naman again we have 3 times our p is equivalent to 200, and our z is the same, 6 meters divided by L, and that is 6 times the square root of 3. Next naman, for the point D, we have here 3 times 400 times 6 meters divided by 2 pi times what is m, we have here 9 meters. Okay, and we can now get our delta sigma z at point A. So we have 3 times 100 over 2 times pi. Wait, let's change that. 3 times alpha x over 2 pi times we have c over alpha y raised to the 5th power. So calculate, x is equivalent to 100, then y is equivalent to 6 times the square root of 2, and that is equivalent to 0. Wait, parang may kulang ng cube. So raised to the 3rd power, that is equivalent to 0.2345 kilopascals. Next, for point C, we have x is 200, then y is 6 times the square root of 3, and that is 0.1702. And lastly, at point D, we have 400 times 9. We have 0.6986. Now, to get the delta z at point A, we simply get the summation of these 3. So, plus 0.1702 plus 0.2345. And that is equivalent to, the summation is equivalent to 1.1033 kilopascals. That is using the Bose-Einstein equation. Now, what if we are going to use naman we are going to use uh, our table here. So what are the components of the column? So we have the points. We have point B, point C, and again we still have point D. Then we have here the R. So how are we going to solve for the R? The R is simply the shortest distance of the point of origin to the point A, or to the point below the location that we are looking for. So this time, at between point A and point B, the shortest distance at the ground is 6 meters. That's why this one here is 6 meters. Now, point A and C. What is the distance at point A and C? So this is point A, this is point C. So what are the involved points? So we have here, okay, so yan. So what are the coordinates involved? We have 6, 6. Okay, so parehas sila. We have here the square root of 6 squared plus the square root of 6 squared. We have 6 the square root of 2. So that is the R. Now for the D, naman, we have it here. So from this point to this point, what are the coordinates involved? So take note, this is 3 meters. So 6 minus 3, so this is also 3. And we have here the 6. So we have 6 squared plus 3 squared. So 6 squared plus 3 squared, and that is equivalent to 3 the square root of 5. Okay. Next, we calculate R over Z for point B. So R is equivalent to 6 meters divided by the depth, which is 6 meters. Therefore, it is R over Z, or the ratio, is equivalent to 1. Next, we have here 6 times the square root of 2. 6 times the square root of 2 divided by Z, which is 6. So that is equivalent to 6. Wait, let me compute. Square root of 2 over 6. That is equivalent to, magka-cancel yung 6. That is equivalent to the square root of 2. But we need it in decimal since the table is in decimal. So that is equivalent to 1.414. So 3 decimal lang kasi yung nasa table natin. So we use 3 decimal. And here we have 3 times the square root of 5 divided by 6. So 3 times the square root of 5 divided by 6. So that is 1.118. 1.118. Okay. So, titignan natin dito is RZ is equivalent to 1, 1.14, and 1.118. Okay. So, balikan natin yung table here. We have here the table. We have the value of RZ, which is 1. Therefore, I1 is equivalent to 0.844. Okay, which is the value here, 0.844. Next would be the 1.414. Now, for 1.414, check natin sa table natin. So, do we have here 1.414? 414? No, we do not have the 1.414. But 1.414 is between 1.4 and 1.6. So we have an interpolation between these values. And upon interpolation, the value would be 0.3011. Okay. Next naman is 1.118. For 1.118, tignan natin, wala rin because 1, 1.2. But 1.118 is in between 1 and 1.20. So, ang gagawin natin is we will be having here another interpolation. So, we will be interpolating these values. Upon interpolation, the value would be equivalent to this 0.645. But again, if the value, like this one 1.414, 1.118 is not in the equation, it's not in the table. It is better for use the formula so as to have a better result or accurate result. Okay, but to show you uh, the method, let's continue. So we have here what is our working equation for the table. We have here delta sigma z is equivalent to p over z squared times I1. P over z squared times I1. Take note, P is varying likewise with I. Okay, so we have here P is equivalent to 100 divided by z squared, which is 6, times the value of I of 0.0844. Next, we have here P is equivalent to 200 divided by 6 squared times we have 0.0311, and lastly we have 400 divided by 6 times 0.0645. Okay, so again, calcu alpha x divided by 6 squared times alpha y, calc. Okay, so for point B, we have x is equivalent to 100, then y is equivalent to 2.0844, therefore it is 0.2344. Okay, next for B we have 200, then we have 0.0311, then that is equivalent to 0.1728. Then lastly we have 400 times 0.0645, and that is equivalent to 0.7167. Now to get the change, just simply add these three. So plus 0.1728 plus 0.2344, and that is equivalent to delta sigma z at point A is 1.124 kilopascals. But if you're going to compare that to the answer for our equation, medyo malayo, because the factor that affected the answer is the interpolation here. Okay, next we have here vertical stress caused by vertical line load. So we are now on unit 2. So we have here a vertical line load. This is not a point load, so this is a line load. You have here a cube per unit length, so pag ganun yung kanyang length. So we have here the soil mass, and we are again still interested in the delta sigma c, that is the vertical stress caused by this line load here. Okay, and it has a distance of perpendicular x from the point of the load. So determined by the principles of the theory of elasticity, delta sigma z is equivalent to 2qz cubed over pi times x squared plus z squared times quantity raised to 2. So this would be our working equation. Again, for this case, we are going again to have two solutions. First solution is by this equation, and so second solution is through the table. Okay, now if we are to rearrange this, and if we are to expand and rearrange this equation, we will have here delta sigma z over q over z is equivalent to 2 divided by pi times quantity x over z squared plus 1 quantity squared. Okay, so the term here will now be equated to z, and we can get the value of z from the table, and multiplying it with q over z, then we can now get delta sigma z. So this will be our table. So x over z, we get the ratio between x and z. Then from there, we can now get our delta sigma z over q over z. Okay, or the value of c. Okay, so if the value of x over z cannot be found in table 2.3, it is better to use the equation so as to avoid possible errors due to interpolation processes. Like what we have shown a while ago, there is a difference between the table and the equation if the values cannot be found on the table. Okay, so saan ba galing na naman itong values natin dito sa table? Came from this chart. So again, we get the value of x over z, project it vertically pag tumama na siya sa ating graph. Then we project it horizontally. Then from there, we get the value of delta sigma z over q over z. Okay, so this will be our working equation for the table method. Okay, yan, or using the table. Okay, so we have here a problem. Refer to figure 3.7 here. Determine the vertical stress increased delta sigma z at point A. So this is point A. While with the following values. So Q1, we have here Q1 is 90 kilonewton per square per meter. And Q2, we have here 325 kilonewton per meter. So X1 here is 3 meters, while X2 here is 3 meters. So the perpendicular distance between X1 and X2 is 3 meters, and the perpendicular distance between Q2 and X, or A rather, is equivalent to 3 meters, while the depth is 3 meters from the surface. Okay, so we are required with delta sigma z at point A. So ganito itsura niyan. So dito we have here the 90 kilonewton, and on the other side we have here, ilan ba yung sa side na to? We have 325 kilonewton per meter. Okay, then the distance is 3 meters, 3 meters. Then we also have the depth of 3 meters. So we have 3, they are the same. So 3 meters here, 3 meters here. So ganyan yung itsura natin. So we are to determine delta sigma A. Okay, so again here we have two loadings here. So what would be the answer? Would be the summation of the contribution of these two linear loads. So it is delta sigma z a is equivalent to delta z at q1 plus delta sigma c at q2, or due to q2. Using equation but in a table form will make it easier and have a cleaner solution, no? Okay, so the values that we need would be the line load. So ano ba yung line load natin? We have line load 1, we have line load 2. Next, we have Q1 and Q2, and we have the X values from point to the, or from the load to the point that we are trying to locate or look for. Okay, so yeah, so load 1 is equivalent to 90 and load 2 is 325. So we have here 90 and we have here 325 kilonewton per meter. Next, the distance. So the distance of the 90 is 3 meters plus another 3, that is equivalent to 6 meters. Next, 300 this 325 is 3 meters rather. Okay. Okay. Now what is our working equation? So our working equation would be, like what I've said, is this one. So let's copy. And let's place it here so we can have a reference. Okay, so placing it here, we have 2qz cubed. So we have here 2 times what is q, we have 90 times what is the z. Our z here is equivalent to 3 meters. Yeah, tama. So that is equivalent to 3 divided by pi times what is the value of x. X is equivalent to 6. Then we have here naman, next we have the z, we have 3 squared. Okay, then raise it to the third power. So bring out your calculator and let's try to solve. So 2 times 90 times 3 raised to the third power divided by pi times we have 6 squared plus 3 squared raised to the second power, and that is equivalent to 0.7639 kilopascals. Next, for number 2, we have here 2 times q, 325 times what is the z, it is 3 meters, divided by what is x. Our x here is 3 and our z here is 3 as well. Okay, so cal q, we have 2 times 325 times 3 raised to the third power. Then we have 3 squared plus 3 squared raised to the second power. Then we have here 17.2418 kilopascals plus 0.7639. We have our delta sigma z at A is equivalent to 18.003 006 kilopascals. So let's have it in third decimal. Okay, next, if we are going to use the table, we will be needing q, x over z, and we have c. Then we can solve for delta sigma z. So again, q is 90, this one is 325. Next, what is the x? So we have 6. Oh no, this is not 6, this is 3 lang ito. So tama pa rin naman, 3 yung nandun. So we have here 6 and 3. So we have x, 6 divided by z. Ang z natin is 3. So this is equivalent to 2. Then next, we have 3 divided by 3 is equivalent to 1. Okay? So from there, x over z, we can now get the value of c. So punta tayo sa table natin. We have this. So yung kanina, yung ano natin, yung 2. So x over z is 2, therefore it is 0.025. While yung 1 na nakuha natin na x over z is 0.159. Okay, so ilagay na natin sa ating table. We have here 0.025 and we also have here 0.159. Okay, so again, our working equation for the table would be c times q over z. Okay, so our c here is 0.025 times q. What is our q? We have 90. Okay, so we have here 90 kilonewton per meter divided by the z, and our z here is equivalent to 3. Then dito naman we have 0.159 times 325 divided by 3. Okay, so ang lalabas dito is 0.025 times 90 divided by 3 is 0.75. Okay, next we have 0.159 times 325 divided by 3 is 17.225. Tama ba? Okay, so plus 17.25. Now to get the total, what do you call this? To get the total delta sigma z at A, which just simply add this 2, and that is equivalent to 17.975 kilopascals. And that is quite near, no? 17.98 plus 18.01. That is quite near. Hindi katulad yung difference nung kanina, nung table with the interpolation. So, medyo mas malayo. Okay? Next, we have here Unit 3, vertical stress caused by a horizontal line load. So, we have here our soil mass, and we need to determine, or we want to determine the vertical stress caused by a horizontal line load. So, for Module 2, it is vertical. Kanina, vertical line load. This time, what would be the vertical stress to be caused by a horizontal line load? And it is located at a distance x from the point of application and has a depth of z from the ground surface. Now, the vertical increase at point A in the soil mass is delta sigma z is equivalent to 2qxz squared divided by pi times quantity x squared plus z squared raised to the second power. Now, if we are to expand and rearrange this equation, delta sigma z is equivalent to delta sigma z over q over z is equivalent to 2x over pi times z times quantity x over z squared plus 1 quantity raised to the second power. And we can equate this term here to c, where we can get the value from the table here. After getting the value from the table, we can multiply it by q over z. Then we can now get our delta sigma z. So this is our working equation for the table. So again, we have two methods. We have the equation and we have here the table. If the value of z, x over z cannot be found in table 3.3, we'll reiterate that it is better for us to use the equation so as to avoid possible errors due to interpolation process. Okay, so let's have here a sample problem. So referring to the figure, due to application of line loads Q1 and Q2, the vertical stress increase at point A, so we already have delta sigma z to be equivalent to 42 kilonewton per meter. That should be in meter. So determine, tama, squared, that's in kPa, sorry. Okay, so kilonewton per square meter. So determine the magnitude of Q2. So here it is a combination of vertical and horizontal. So we need to find the components of Q1, components of Q2 vertically and horizontally. Okay, so redrawing the free body diagram, we have here Q2 and it is inclined 45 degrees with respect to the horizontal angle. Therefore, the value of Q2H and Q2V are equal because our inclined plane is 45 degrees. Therefore, Q2 V is equivalent to Q2 sine 45 is equivalent to Q2H. Okay, so since we have two loads here, what we're going to have is the summation. So delta sigma z is the summation of Q1 plus Q2 vertical and Q2 horizontal. So this will be our working equation. Delta sigma za is equivalent to delta sigma z Q1 plus delta sigma z of Q2 vertical plus delta sigma z of Q2 horizontal. Okay? So, let's go back. Ano ba yung equation natin for delta sigma z na vertical? So, wait. Ito yung ating vertical. Let's copy that. So we can have a reference here. Okay. So delta sigma z at A, underscore natin yan. So at A is equivalent to, this is the vertical, plus may isa pa tayong vertical. This is this is Q1. So we have here Q1. Okay. Then may isa pa, we have Q2. May Q2 tayo. Plus we have Q2 instead of Q1. Q2 vertical. Then yung horizontal natin, our working equation for the horizontal is this one. So we copy this. Then we can now go back and paste it here. Okay. Control paste. Okay. So this is for Q2 horizontal. What happened? Hindi siya nag-ano. It should be Q2 horizontal. Okay, yan. Okay, so we will be putting our values here, or we can substitute. Now, we already know the value of delta sigma z at A, which is equivalent to 42 kilopascals. And Q1 is 292. Z is equivalent to 3 meters. X is equivalent to 3 meters. And Z is equivalent to 3 meters. Now, for Q2, this is vertical. For the vertical, Z is same. C is equivalent to 3. Then X is equivalent to 7.5. Z is 3. Then, ang matitirang unknown natin would be Q2V is equivalent to Q2H times 2 times X is equivalent to 7.5. Z is equivalent to 3. Then X also is equivalent to 7.5. Z here is equivalent to 3. Okay, so if we are to input it here, yeah. So we have here Q1, Q2, Q2. Okay, take note that Q2V and Q2H are the same. Diba? Q2V and Q2H are the same. And that is equivalent to Q2 sine 45. Take note that the sign here should be in it should be in degrees. Okay, so naka-degrees tayo dito to get the value. So yeah, so inputting and substituting, shift solve. Q2 is equivalent to 2653.11 kilonewton per meter. Okay, here it is best if we are going to use the equation, because mas madaling maghanap if we are going to use the equation. But you can use naman yung table natin if you want to prefer, or if you prefer that. Okay, so if you prefer this. Okay,